Okay, so we're starting off by just looking at the different types of functions that we find in trigonometry. And the first one is the sine function in the far left, the middle one, the cosine function, and the tangent function. But as you can see with these bullet points, they do summarize the basic points about these functions and the formula itself. So as you can see with sine, you do have y is equals to a sine in the bracket k theta plus p plus q, right? And p and q are shifts, and also k also determines the period, and a is also the amplitude, right? So those are the key things that you should know by now. But generally, the two things that you could say that are the same for both sides is that one, with the period for the sine function is the same to the period of the cosine function, with the k um, acting the same way, in a sense that if k is greater than 1 or k is less than 1, then the period decreases as well with the cosine function. But you also find that it also applies for the tangent function. But the difference is that the tangent function, its period is 180 degrees over k. And this k is a positive k. That's why they put the two lines next to it. So it's a positive k. And yeah, and then from there you can also see that. So you always put a positive k whenever they put k absolute. This means an absolute of k. So it's a positive k. And then you can also see that when we talk about P, it's a shift to the left and the right. When we talk about Q, it's a shift up and down. And then you also find that, okay, we have the negative um, um, reduction, the negative reduction of sine and cos. And then also here, we also have something that is special about the tangent function, which is one more thing that is more different from it, is that it has an asymptote, and that would be your generalized asymptotes. Okay, so when we look at the sine function, you do see that we have what we call a single cycle or one period. And this one period starts from 0 to 360, right? But now if it's starting from 0 to 360, we can divide this 0 to 360 into four pieces. And those four pieces is what we call the quadrants. And therefore we would have the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Now with all these different quadrants, what you find is that the answer, the solution, if you just look at the graph itself, this is a sine graph, right? If you look at the graph itself, you can see in the first quadrant, which is between 0 to 90 degrees, all the answers is positive. It's positive. It's above the y-axis, because above the y-axis, it's above the x-axis, and it's on the positive side of the y's, right? And also in the second quadrant, you see that sine is positive, right? And then you see that this sine graph, once it gets to 180 to 270, it's negative. But then when it's 270 to 360, it's still negative. And so that's why we find that it's negative, negative, positive, 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 negative, negative, right? But so this is just an illustration of what we need to talk about, and this is about reduction formulas. Now, reduction formulas, if you think of it, in the first quadrant where your degree is an acute angle, and acute angle is something that is less than 90, right? It's less than 90. Any angle that is less than 90, when you put it into either sine, cos, or tan, you would get that the answer should be positive, right? And whenever it gives you a positive number, that means in the first quadrant it shall be positive. So all of these would be positive, right? But now when you get to the second quadrant, when you have a solution or an angle that is between 90 to 180 degrees, you'd only find that it is sine that is positive. Only sine is positive. Everything else is negative. In the third quadrant, you'd find that only tan is positive, and in the fourth quadrant, you'll find that only cos is positive. So that's a very important key thing you should understand by now. But now, thinking about it, how do we use this in this observation? So you could see, if we're talking about all the first quadrant, all trigonometric functions are positive, right? But at the same time, when we look at the second quadrant, you'd see that if we'd had a specific angle being theta, right, and we'd say 180 minus theta, that would give us a positive sine theta. But for that same sine theta, if we take that theta and then we put it in cos and we say cos 180 minus theta, then that will give us a negative cos theta for a certainty, right? We have a certainty that it will be negative, right? And so tan as well. And then you also have your cofunctions where it's sine 90 degrees plus it would be cos, positive cos. And then if it's cos, it becomes negative sine. If it's cos 90 degrees plus theta, right, it becomes negative sine. And maybe a good way of just thinking of it, just a quick way of thinking of it, is that if I'm saying cos 90 plus, right, it's a cos, but then cos is what in the second quadrant? Because this 90 plus, right, this 90 plus will land into the second quadrant, therefore the only thing that will be positive there is sine. Then you change cos into sine, but because it started off as cos, right, and it said I am cos, but then I am moving to the second quadrant, 90 plus theta, that would make me negative, right? That's just another quick way of thinking of the cofunctions, and then you can see the rest. That's how we would do it. So then here's some examples that we could do. So the first one, 5.1, if cos 23 degrees equals to p, express without using a calculator the following in terms of p. So now we would have 5.1.1 where it says cos 203 degrees. Now to cos 203 degrees, you should notice that it's actually 180 degrees plus 23. But then because of our reduction formula, we find that when it is 180 plus that angle 23 degrees, we find that it is negative cos 23, so it's negative p. But you also find the same thing with sine 293 degrees. Then we'd use the fourth quadrant. It's in the fourth quadrant. 293 is in the fourth quadrant, so it's minus 67. And minus 67 would find that we minus sine 67. But then minus 67 is not what we need. We need 23 degrees. So then we also see that when we say 90 degrees minus 23 degrees, then it would give us minus cos 23 degrees. And then the final answer is supposed to be positive, right? It's supposed to be positive because sine minus no, it's supposed to be, yeah, no, yes, so it is correct. It is minus 90 degrees, right? Minus cos 23 degrees, and that just gives us minus p at the end again. Okay, and then we look at the other one. So now it's just a reduction on its own again. And then once we do the reduction, we just follow the steps, and then we would find that that's how it gives us, right? But now let's talk about solving equations. Now, with solving equations, especially in trigonometry, is a bit trickier. For instance, if you're given tan theta is equals to 5, and then they say with theta, which is the solution that you're looking for, is supposed to be between 0 degrees to 360 degrees, what you do is you would use the inverse, and then that would be arc tan 5, and then that will give you 78.7 degrees. But now this 78.7 degrees, you could agree with me that it is in between 0 and 90 degrees, so it's in the first quadrant. But in the first quadrant, all of them are positive, and so you can also see that the 5 that we're looking at was a positive number. But now think about this: since we have that 5 is the positive number, therefore it means that tan theta is a positive as well. But where else can tan be positive? Is it only in the first quadrant? And the answer is no. It is also positive in the third quadrant, correct? So because it's also positive in the third quadrant, and the third quadrant is basically 180 plus that angle, then we would say 180 plus 78.7 degrees. That would give us 258.7 degrees, and that would be your solution to this. This would be another solution to your equation, and so you find that the final solution is actually 78 degrees, 78 0.7 degrees and 258.7 degrees. And note that this is in between 0 and 36 degrees. So basically, the difference about just normal solving for x is that when you look at trigonometry, you need to find all the solutions in that particular interval. Unless what happens when we remove or not require the interval, right? If we don't require the interval, then that's where it brings us to the general solution. So there are 4 steps or methods to finding the general solution. It's determine the reference angle, use the cast diagram, right? Find the angles in the intervals, and then check your answers using a calculator, right? So here's an example from a past paper. Determine the general solution of sine 2x is equal to 4 cos 2x. Now in this one, what you can do is you can take the cos 2x and divide it onto the other side, and then it would be sine 2x over cos 2x, but this is an identity, therefore you would say it's tan 2x that's equal to 4. But then when you say tan, when you apply the reciprocal or the arctan onto 4, then you would find that it would give you 75.96 degrees. But now the 75.96 degrees is just our angle or reference angle. So now we take that reference angle and say now it's actually equal to 2x plus 75.96 plus k, right, times 180. And why do we say k plus 180? When we're looking at the general solution, what we're looking at is actually the periods, right? And remember when we started off that when we talked about periods is that the period here is related to 180k. But now the difference is that for cos, so for cos and sine, it will be 360k or k 360 and k 360, but here it will be k 180, and the k represents the period in which this particular number is, and therefore that's why we'd say k is an element of integers, right? But because we had 2x, we divide on everything, and then you would find that 75.96 is actually 37.98, and obviously the half of 180 is 90, and that's what you would find. And then generally this is how you would have done this particular problem. Other than that, I really hope this is helpful. I'll see you next time.